So last section we're going to look at is 1.3. Okay, this section is on what we call functions. Functions are something that when you draw them, they have a certain look to them. So I'm going to describe what that look is. In the rent-a-car problem we did yesterday, if you remember, that was the formula that we had. It was like 20 cents per mile, and then I think it costs like $15 to rent the car. The x variable and the y variable have different names. You can call them the x and the y variable, but other names you might see for the x variable, it's called the input, the domain, or the independent variable. It's three names that all mean x. When you see range, output, or dependent variable, those names all mean y. And when you think of a function, right? Think of a function is it's kind of like a machine. You plug something, you put material into the machine does something with the material, and you get a different product out of the machine when you're done. That's basically what a function is. You have an x value that gets plugged into a formula. Something happens to the x value. Maybe you add 5 to it. Maybe you double it. You do something to it. And the answer that comes out is a y value. That's why x is called input. It's what you put into the function. Y is the answer you get when you're done. So, algebraically, a function is basically this. If you plug in one number into a formula, you get exactly one number as an answer. Here's an example of a function. Y equals 3x. If I plug in 4 into that formula, what will I get for y? 12. Will I get another answer besides 12? No. If you plug in 4 for x, you will get 12 for y. There is no other answer. That's a function. Here's something that's not a function. Let's do it similar to the one we did in the homework. If I plug in 36 for x, what is the square root of 36? 6 and negative 6. That's not a function. You plugged in a single number for x, 36, and you got two different answers when you were done. Not a function. You have to get just one answer. That's what this is. Any question on that? Yeah. Yep, this time. So, yeah, I already said this to you pretty much, but domain, that's what you're allowed to plug in. Range is the answer you get. Value, that's important. If you had a formula like this, y equals 3x, what numbers are you allowed to triple? What numbers in math can you triple? What? 4? Is that what you said, 4? Yeah, you can triple number 4. What else can you triple? What is it? Anything, right? You can triple any number. There's no limit. You can triple any number you want. So every single number would be valid to plug in for x. Now, how about this? You can plug in any number you want for x there except one number. Does anyone know what number you can't fill in for x here? Is this something you're not allowed to divide by?
2.
So yeah, what couldn't you fill in?
2.
You can't fill in a 2. So the valid inputs to this formula is every number except 2. This is how you would write it. All values except x equals 2. So you can write all values except x equals 2. Except. Or you could just say x is not equal to 2. You could say it that way as well. So when you have a fraction, you have to be careful that you never divide by 0. If you could, then you have to say that value, like 2, is not part of the domain. That's not a valid number you could use. How about something like this? Square root of x minus 2. Whenever you take a square root, what kind of number do you never want to have where I just circled? You don't ever want that number to come out what? Negative. 0 is okay. You can take the square root of 0 and get 0. But you never want this to come out negative. So, anybody think they could tell me what you could use for x's in that problem? Like, could you use negative 50? Could you plug negative, Sam? No. If you plugged in negative 50 and minus 2, you'd have negative 52. Negative 50 is too small. Well, how small can you go then? What's the smallest value you could fill in for x, yeah?
Be greater than 2, or like with 3.
Why? What would happen if you plugged in 2?
If you would do 2, then be 2 minus 2 would be 0.
And that's okay. You can take the square root of 0. So you were right. It is any number that's greater than or equal to 2.
You to make up that number?
Yeah, come on. Okay, but those are the only two things that you have to be careful with when we talk about domain. Is there any way you could ever divide by 0? If there is, make sure you don't. And when you have square roots, is there any way that you could ever take the square root of a negative? If there is, tell me what I can use for numbers that won't let that happen. So in this case, anything greater than or equal to 2. Right, so I'm going to let you guys copy that down. And then we'll take a look at it. All right, so in general, just to keep in mind, the kind of numbers we're talking about when we deal with domain are real numbers. In Algebra 2, you probably studied complex or imaginary numbers. We're not doing that. Okay? We're just focusing on real numbers. Now, this is the notation that I keep using when I describe functions. That's y equals, like y equals mx plus b. This is another notation. It means exactly the same thing as what's above it, except it's called f of x notation. How many people have seen functions like that, f of x? Okay. So same idea, just a different way of writing. Does anyone have any questions on those notations? The graphing calculator uses the top, y equals. All right, so let's try this one. Find a complete graph of the square root of x minus 3. So that means find a window that looks good. And then I want to know the domain and the range. Domain is usually something we can figure out before we graph. Range, not as much. So let's start with domain. Can someone remind me, what is it that you do not want to ever have happen with a square root? Yeah? You never want this thing that I just circled to be negative. So if you don't want that to be negative, then tell me what numbers I can use so that won't happen. That's my domain. What could I fill in for x so that this never comes out negative? 0 is okay. Negative is not. Yeah.
So you start with 3.
And then you could use all numbers from 3 and up, right? Anything greater than or equal to 3. So there's two ways you can write it. You can say that your domain, which is your x's, is greater than or equal to 3. Or you can write it as what's called an interval, which is the low number you're allowed to use, comma, the high number. The lowest number that you can use here is 3. The highest number that you can use, well, there's no highest number. It just goes up forever. So we use infinity. Now, when we talk about 3, are we allowed to include 3 or not include it?
Yes.
Yes, we can include it. What symbol did we use yesterday on a number line that represented you could include the number? We used a closed circle, but what was the other one? Yep. A bracket. That means you can include that number. What symbol did we use when you couldn't include the number? This was the symbol that took the place of an open circle. Yeah? A parenthesis. The reason I put a parenthesis on the infinity is because when you put a bracket on something, that means you can reach and include that number. Can you ever reach infinity? No. So you never put a bracket on it because you can't reach it. That's another way to write the answer. This is called an interval. This is called an inequality. If it asks you to describe it, you can do it any way you want. But if it's a multiple choice question, you may see a choice like this, and you'd have to know what it means. So this means greater than or equal to 3. It's the low value, comma, and then the high value. Bracket means include the value. Parenthesis means don't include it. So like if you wanted to write this, you could do that. Now that means everything from 3 and up, not including 3. But that's wrong for this problem. You do want to include the 3. Okay, so let's put that in and see if we can figure out the range. So we're going to turn it on. Go to y equals. If you have anything that's in there, we can clear it out. And to do a square root, you press second, and then it's the 5th button down on the left. Second, and that gives you a square root. And we want to type in x minus 3. Now, before we graph it, we need to check our window. But is anybody not able to get that typed in on Y1? Okay, so what, do you have this screen on your calculator?
Yeah.
Okay, so now you press, if there's anything there, you can clear it. So I'll just clear it and start over. Press second, and then the square root button is the 5th button down on the left. Did it put a square root in? Okay, now X button is the second one over and the second one down from the upper left. So press X. The minus sign is over on the right. Don't use the negative at the bottom. That won't work. Do the minus on the right. And then a 3. And that's it. Now, set your window. We already know the lowest it's going to go is 3. When I set my window, I like a little extra. Okay, just so I can see a little past. So what do you think a good minimum value would be? Yeah. So yeah, we could do 2. You could do 1 or 0. That'd be fine. I don't want my x max that big. Let's just do 10. Let's do the normal. And let's do the normal values for the y min and y max. Negative 10 and 10. So that's what you want to put in for your window. So the only thing we adjusted from the standard value was the x min. Put it on 2. And hit graph. Okay. And that's typically how a square root function looks. A square root function is half of a parabola on its side. That's what you should be seeing. How many people got a graph that looks something like that. Okay. So I can tell from the graph, it doesn't go past, remember, this is 2, this is 3. 0's off the screen. We didn't use it. I can tell that this graph starts at 3, and it goes to the right forever. That I can see. That's my domain. My range is the up and down. Does this graph go down forever? No, if it doesn't go down forever, then you're telling me it has a lowest point somewhere. What's the lowest that this graph goes down? 0. That's the lowest that it goes. And the highest, well, it just keeps going up. It goes up, excuse me, slowly, but it will keep going up. Think of this as like a parabola. The parabola will keep getting wider and wider. So you could say your range are all numbers greater than or equal to 0, or everything from 0 as high as you want to go, including 0, not including infinity. And that's how you describe the domain and the range of that. Any question on it? I'm going to skip over that one. So one thing they might ask you to do on the test is evaluate. Very simply, what evaluate means is to take a number and fill it in and tell me the answer. That's evaluate. They'll give you a number they want you to plug in. They'll also give you a formula to plug into. So we're just going to try a couple values. Let's try plugging first -2.
Can you go back up?
Yep. We're going to plug -2 into our formula and see what we get. We're going to figure out this. So what does it say to do? To find a particular value, plug in the number they give you, and then evaluate. So they're giving me -2. So everywhere you see an x, you're going to change the x to a -2. Yeah. Yeah. So let's fill it in. So instead of x squared, it's going to be -2 squared plus 1. Curtis, what's -2 squared give me? 4, and then plus 1? 5, that's it. So you take the number they give you, you fill it in, and you simplify it, and that's the answer. Any question on how we got 5? You could do that with a bunch of different numbers. Let's try it with A. What do I get if I replace all the x's in my formula with a's? What is it? So what would you put down? Yep. Plus 1. So this time, when you fill in a variable, you can't really simplify it. You've plugged in what they told you to, and you're done. It's a squared plus 1. Okay. Any questions on that? So the directions in this problem were to find, and they told me those two things. So they told me the -2, that's like the -2, I didn't just make it up. That's what they told me to use, and they told me to use an A. So they'll always tell you that what they want you to plug in. Could be a number, could be a letter, and they'll give you the formula to plug it into. And we already did that. Okay. So I told you that for something to be a function, you plug in an x value, and you get how many answers for y? Only one. Okay. So something like, let me do this again, y equals 3x. That's good. That's a function. Right? Y equals 3x. That would look like a line going through the origin, and if you plug in a value for x, like 7, 3 times 7 is 21, that's the only answer. You'll never get a different answer. Something like this, not a function. It's a square root, and if you plug in like 25, you're going to get two answers, 5 and -5. And if you graph it, I technically can't graph plus or minus at the same time, but what I can do is I can kind of cheat and do them separately, like that. So I cannot put in that plus or minus sign. But watch what happens if I graph this and pretend like it's one picture. Let me do zoom 6. There's the top half of the square root. There's the bottom half. As I said before, it's a parabola on its side. That's not a function. And another way you can tell it's not a function is to go like that. What type of line is that? Because it goes up and down.
Undefined.
Well, the slope is undefined, but even simpler, it's vertical. So there's a thing called the vertical line test. If you could take a vertical line, put it in your picture, and it hits the picture more than once, like in this case it hits it twice, then your picture is not a function. So that's a visual way to tell if something is a function. Take your picture, draw a vertical line. If it only hits it once, you're good. More than once, no good. How about this? Would that be a function or not a function? That wave in black. What would it be? Yeah, that would be a function, because if I move this red line through the picture, it never hits that wave more than once. Okay? This would be like my x-axis. This would be my y-axis. And the thing I drew, in black, that's my picture. It's a wave. That's a function. It never hits it more than once. How about a parabola? Would that be a function or not a function? Yeah, that's fine. Because if you draw a vertical line, I don't care where you put it, it's never going to hit the parabola more than once. No matter where you put it. Because to hit more than once, the sides would have to be vertical. The sides in a parabola never quite get vertical. They get close, but they don't. Questions on that? All right, let's try this one. So, domain and range. Is this another domain and range? So it says, find a complete graph of 16x minus x cubed and determine the domain and the range. Okay, so first thing, we got to type that in. If you have anything else typed in, just clear it. So I've got 16x minus. How do I do an exponent of 3? What do I press for that? Yeah.
With the arrow below the clear button, right?
Yep. And then press 3. There you go. So you should have a graph that looks just like that. If you keep typing right now, don't do this, but if you keep typing, it's going to stay in the exponent. If you had something else you wanted to type and you didn't want it in the exponent, if you press the right arrow, it brings you back down, so you're not in the exponent anymore. I didn't have anything else I wanted to type, so that wasn't a problem. Right, let's do Zoom 6. All right. Do you think that's a good window where we can see everything that's happening? I think we just need to adjust this one way. Which way do you think we need to adjust it? Left and right or up and down?
Up and down.
Up and down. We need to go higher and lower. So up and down would be y or x? Y. Let's set our y min. Let's try like negative 50. Let's try positive 50. So that's just going to zoom us out so we can see higher and lower. Let's hit graph again. See what it looks like now. That's a much better picture. Now, you can keep going. If you want to try setting your window like negative 100 to 100, you can. But all you're going to see is that that just keeps going that way, and that keeps going that way. That's what it looks like. So, let's start with our domain. Are there any values? Well, actually, think of the two things you can't do. You cannot divide by 0, and you can't take the square root of a negative. Would you ever divide by 0 in that formula? You think, Lucas? No. You're going to multiply by 16, and you're going to cube something. There is no division in that problem. So you never have to worry about dividing by 0. How about square roots? Would you ever be taking a square root in that problem?
No.
No, there's no square root in there. So you're never going to be taking a square root, and you're never going to be dividing by 0. So what do you think your domain is in this problem? All real numbers. Yes. So the domain is all real numbers. There is no restriction on what you are allowed to plug in for x. How do you think I would write that? Using an interval. Yeah.
I don't know, but can I go to the team?
The team? Yeah. Anyone have a guess? Yeah?
A 1 and then like another infinity thing.
A 1. So what's the, if we said the domain is all real numbers, what's the lowest number you can think of?
0.
Even lower. What's the highest number you can think of?
There is no number.
What do you call the highest thing?
Infinity.
Infinity. So that's the highest. So what's the lowest?
It'd be the same thing.
Negative infinity. That's how you write all real numbers. This is the lowest. This is the highest. That basically means everything. So the domain, we just have to be careful about dividing by 0 and square roots. Doesn't happen in this problem. And how about the range? The range is the highest and the lowest that the graph goes. Think about the range for this one. Yeah.
Wouldn't that be like the peak of one of them and then the lowest area of one of them?
So you're saying there's a highest value that the graph reaches and it never goes higher than that?
Yeah. Would that be right?
If there is a highest value, then yes. but do we think there is a highest value? Like if you have a parabola like that, I would say yes, there is a highest value. It's right there. And it never goes higher. Yeah?
All the numbers.
The range here is also all real numbers because it never goes higher than, well, I mean, it never stops going up and it never stops going down. So the range, all real numbers. Never stops going up, never stops going down. Any question on? It takes a little practice to get used to doing the domain and range. It's something we'll talk about several times. That's two. So the last two things we're going to look at is a formula that we're going to plug into. And this is a formula for what's called projectile motion. And that's the formula. Projectile motion, you can think of like throwing something, and it travels like that. It's kind of like an arc. And this is always the formula that you use for projectile motion. You all set? Okay, perfect. Thank you. To figure out how high, like if you were to throw an object, how high it's going to end up going, it depends on two things. How fast did you throw it initially? How hard did you throw it? And how high were you when you threw it? Like, if you throw something off a roof, you might already be standing 20 feet off the ground. So it's already 20 feet in the air when you throw it if it comes off the roof. If you threw something from ground level, then that would mean it starts on the ground. So in a problem, they will tell you these two numbers, the initial velocity and the initial height. You'll be given those. This negative 16 is something that's always there. It just stays the same in every problem. And you don't have to memorize that formula. That's something you could just put on your reference sheet. It will always use units of feet and seconds. In other classes, you might use metric. We'll always use feet and seconds in this class for this formula. Does everyone have the formula? Okay. So this is about a rocket that we're going to launch. And it's being shot from ground level. So that tells you something in the formula. So being shot from ground level. And it has an initial speed or velocity of 64. It's feet per second. And we're going to use that formula to figure out something. First thing they want to know is when will the rocket be 50 feet above the ground? When will it be 50 feet above the ground? So let's see if we can just fill in the numbers to our formula first. So the left-hand side represents the height. The height. What are they asking me for the height to be in this problem? 50. So 50 is going to go right there. Equals negative 16t squared, always comes next. Plus the initial velocity times t. What's the initial speed in this problem? Times t. Plus 64t. And And the last thing is plus the starting height. What was the starting height? Which means what? 0. We don't need it. So we don't need it. All right. So let's do that on the calculator. So we've done something kind of like this before. We're going to put one side of this equation in y1. So we're going to put the 50 in y1. We're going to put the right side in y2. So we're going to graph two things at the same time. Let's put in 50 and negative 16 x squared plus 64x. You can't use t, you have to use x. Even though we use t, the calculator only uses x. So we're going to draw two things on the screen. And what do you think we're going to look for? Yeah, we're going to look for the intersection. Now keep in mind, you're throwing an object. How many times could it hit 50 feet exactly?
Twice.
Could hit it twice. It could hit it 50 feet on the way up, and it could hit it again on the way down. Let's see what happens. So we got to go at least as high as 50 feet. So I would set your y max, I don't know, I'd probably do 80 feet. Does it make sense to have negative feet in this problem? No. So we don't have to worry about a negative value for the height. Now, x is time. Could you have a negative time value? No. 0 would represent the start of the rocket flying. -1, it was just sitting there, it wasn't doing anything. So I would set your x min at 0. X max, you could leave at 10. Let's hit graph. There's a line at 50. There's an equation that models how the rocket is going to travel. And we want to know the intercept. So second calc, option 5. And did we do intersect yesterday?
Yeah.
We did? Okay. So you pick a point on the blue, on the red, hit enter each time. And now the guess is important because there are two answers. The calculator will give you one at a time. So I'm going to put my guess closer to the one on the left. If somebody else can do the one closer to the right, that would help out. I'm closer to the left. I hit enter, and it tells me that on the way up, my object will hit a height of 50 feet at 1.06 seconds. That's on the way up. And how about on the way down? Does anyone have the time? I mean, it looks like it's going to be back on the ground at 4 seconds. So it's probably between 3 and 4 somewhere. Yeah?
Yeah, about
2.9. What is it? 2.95. Okay, so not quite 3. So those are our two times. Any questions on how to find that second intercept? Yeah.
I'm struggling to graph it, like on my calculator.
To graph it?
Yeah.
All right, let me take a, because we're going to be done in like a minute. So let me see. I'll look at yours and we'll see what went wrong. So the last question is, what is the maximum height and when do you hit it? Well, let's go back here. The maximum is something you can calculate. So let's press second calculator. Which option here do you think would tell me the maximum?
Alright, the one that says maximum.
Oh. So let's do option 4, which is maximum. Now, do we want to find the maximum of the blue line or the red one? Yeah, the red. The blue is just a mark at 50. We want to know how high does the rocket go, and that's the red one. Right? It goes up, and then it comes down. So if I move my cursor left and right, I'm on the blue. Hit the up arrow, and it'll give you the red. If you hit the up arrow again, now you're back on the blue. Back on the red. To do a maximum, it's kind of like doing an intercept. You have to hit enter 3 times. The first thing it'll ask you is pick somewhere to the left of where you think the maximum is. Then pick somewhere to the right. What you've done is you've given the calculator 2 marks and said, hey, there's a maximum in between here. That's where I want you to look. Because there's only one maximum between those 2 lines, the guess doesn't really matter. You can basically just hit enter. You can move it if you want. But that is what I got. So what do you think the max height is based on those 2 numbers? Well, it has something to do, like it told us right there. The answer to the question is right where I circled. So what do you think the maximum height that red line hits is? Yep. 64. Yep. So the max height is 64 feet. And when do you hit 64 feet? 2 seconds. You know, it's estimating. Your calculator might say like 1.999. It's the same thing. It basically is 2 seconds. So max height equals 64 feet, and that's at the 2-second mark. Okay, so finding a maximum, something we never did before, that's how you do it. Okay, questions on it? All right. So, on page 30, I might change that slightly. So, we're going to skip the 50 to 52. And the 45. Okay, so that's 3 through 19 odd. 24, 32, and 33. And we'll take a look at that tomorrow. I will pause the video, and I'll add the test topics at the end of the video before I upload.